On July of 2022, we actually got images from JWST telescope of Jupiter, and it was really a stunning image to check out. We saw the moons, we saw some of the rings that were present, but little do we know that they are going to explore more about Jupiter in this new article here, which states that Jupiter's atmosphere is really shown in full detail and shows some incredible characteristics here to think about. One, of course, is what is the incredible thing that is seen at the equatorial region, and in terms of how vast it is, and most importantly how this is compared to Earth. And finally here, what is the impact of such results here, not only in terms of its speed but also in future exploration of Jupiter. Now, looking at the width of this particular region here, this here is known to be part of the Jupiter's atmosphere that is identified, or was identified previously, to be an unseen high-speed jet stream that extends over how much? Around 3,000 miles in width, that is at the region of the Jupiter equator. Now, in addition to this shows the incredible power of the observation from JWST telescope in terms of studying this incredible phenomenon of this unique take on Jupiter's region here. Now, previous results here has shown that the hazel and the unclear region at the equatorial part here was really difficult to explore, but with the help of JWST telescope capacity, we're able to actually see how the near infrared region of James Webb is able to unleash this particular region here of Jupiter as shown in the images. So, looking at the details about this, it says here that the image that was produced of July of 2022, that was about a 10-hour interval, which is pretty much a day in Jupiter. And based on this image produced here, this actually gives us a little detail about this particular speed of this region of the high-speed jet region in terms of the value. And so this here not only looks at a small picture of many things, but also what attitude are we looking at. And so looking at how this here shows the differences between Jupiter and Earth, it shows also that it possesses not only layers of the atmosphere, but in terms of other missions which focus mainly on the lower atmosphere of Jupiter, this of course, which is a lower region, which shows significance of not only storms but also, most importantly, ammonia ice clouds that are found. Webb was able to provide, due to its wavelength, shades of the upper atmosphere of Jupiter and its features. Now, in terms of the upper atmosphere, which is in this case a higher altitude of around roughly 15 to 30 miles, this here, which is also approximately 25 to 30 kilometers above the planet's cloud tops, this here, due to the near infrared spectrum, which traditionally would be really blurry, but this here, according to James Webb's advanced imaging, this resolved it to show a finer and brighter hazel band. Now, the high-speed jet stream of Jupiter at the lower stratosphere is around 25 in the region miles or 40 kilometers above the cloud, but the jet stream boasts speeds that is around 320 miles per hour. Now, if you look at it in terms of kilometers per hour, that is really huge, around like 515, which is around double a category 5 hurricane on Earth. That is huge, definitely. And this here reveals not only in terms of the speed of Jupiter's here at that particular equatorial region, but also the image here and the analysis is a combination of both the James Webb and the Hubble Space Telescope, and this shows scientists the insights into the three-dimensional structure of the storm clouds and rate at which these storms developed in Jupiter's equatorial region. Now, researchers, they anticipate truly conducting additional observations with James Webb Telescope to assess whether or not the jet space or attitude undergo changes over time, because this image here is just a one-day result here, but looking at it over time is going to be interesting to see the combined efforts by researchers using James Webb and Hubble Space Telescope, and most importantly further our understanding of Jupiter's dynamic atmosphere processes. Now when you zoom in closely into the image of Webb based on Jupiter in this case, according to Len Fletcher, a team member at the University of Leicester in the UK, there is a possibility that the strength of the newly discovered jet is linked to the oscillations of the stratospheric pattern of Jupiter. Now, as a result of that, they anticipated that this jet may exhibit significant variation over the next 2 to 4 years. So what is it going to look like in the next 4 years or 2? If they're checking the data again, will there be a huge gap between the 515 kilometers per hour? Will it be more than that? Will it be less than that? Will it also depend on the season at that particular region at the equator? Or will there be some interesting disaster, let's put it that way, instead of a hurricane like a tornado that may influence that particular region's speeds in terms of how high jet it is, or most importantly, how will the lower atmosphere impact the speeds at the upper atmosphere of Jupiter? So it's really interesting to think about all this information right here in this article and the results that is produced by James Webb Telescope of Jupiter's equatorial region, which is really of a high dense region. I mean, compared to the red spot, which is really like off the chart. Looking at how the speed of that is, it's going to be interesting to see what result we get from that, or maybe there is a result from James Webb already, we don't know at all, but from the equatorial region that is just mind-blowing. So I'm interested to know your thought about this in the comment section down below. By that way, we can talk to you soon. Stay smart as always and believe in yourselves.